So again, if we look at it, refer to the previous video on the free radical substitution from that point, and that's where I'm carrying on from. What I was talking about in the last video was that we have again used up a free radical and then generated another free radical, and then that chlorine free radical that we have generated can take part in this reaction again, and it's a bit like a chain reaction where you're generating another methyl radical, and that methyl radical can then take part in this reaction, and it keeps on going until we have what is known as a termination step. Termination, if you think about what termination implies, it means a stopping step. Now, a termination step here, they could have one of three. We could, in theory, have a chlorine free radical reacting with another chlorine free radical to make a chlorine molecule, although that could be considered to be a termination. It's not the one that is preferred by the exam board in general, depending on the type of question. The other one we could have is having a methyl free radical reacting with another methyl free radical to form what is known as C2H6 ethane. And finally, we could in theory also have a methyl free radical. I'm just going to use this space up here, reacting with a chlorine free radical to form chloromethane. In the previous page, or on the previous page, we generated a chloromethane. There is nothing to say that that chloromethane, say for instance CH3Cl, cannot react with another chlorine free radical, and in this instance what we might get is hydrogen chloride again plus a CH2Cl3 radical there. Alternatively, we could have that, the free radical that has been generated again, that CH2Cl3 radical, remember the radical is on the carbon, reacting further with another chlorine in another chlorine molecule, and for instance we could have further substitutions happening on what was the original methane. So CH2Cl2 would be formed plus another chlorine free radical, and again there is nothing stopping that reaction happening or going on, because this chlorine free radical that we've generated can then take part in this reaction over here, and secondly this radical can then take part in this reaction over here again. And what we could do in theory is have further substitutions again. We could have this molecule then that has been generated take part and react with a chlorine free radical again, and you would generate hydrogen chloride in this instance plus a CH2 sorry, not CH2, you would generate a CHCl2 free radical, and then that can take further part in substitution again if we write it out, Cl2. So in theory what we could have is further substitutions so that we form a CHCl3 plus another chlorine free radical, and in theory we could have further substitutions where all the hydrogens have been